Hello, everyone. I'm Dr. Reza Said Kandezi, and today we are going to walk through the IEEE 1680 standard. Uh, this standard is all about how we as engineers can make electronics in a way that's better for environment. Instead of just reading through rules, we are trying to understand the purpose behind this standard and why it exists, what kind of impact it has on our design process, and how it changes the way we think about our role as an engineer. Now, let's look at why this standard even matters. Right now, the world produces more than 50 million metric tons of electronic waste every year. That's roughly 5,000 Eiffel Towers worth of junk electronics, and it's every single year. So sustainability is not just a buzzword anymore. It's a real design requirement. We need to think not only about the cost and the performance, but also about how our product affect the world. So electronics are everywhere, and their environmental impact has gotten just as massive as their role in our life. So IEEE 1680 is more than just a guide. It basically pushes us to include environmental thinking directly into the design process. So unlike a standard that just care about the safety or performance, this one looks at the whole life cycle of a product, from mining the materials to the disposing of the product. Now, that 50 million metric tons of e-waste is not going anywhere unless we make changes. Of all that waste, only 17.4% gets properly collected and recycled. The rest of it is landfills, incinerators, or worse. So, studies shows that about 70 to 80% of the product's environmental footprint is locked in during the design phase. So government and regulatory agencies are stepping up and enforcing some stricter rules. So engineers also have to keep up. That means we can't just tack on sustainability at the end. We need to design it in from the start. So working with IEEE 1680 means you are not just solving technical problems, you are actually taking on the ethical and environmental impact of your design too. Now, before this standard, there were no consistent way to approach sustainability in electronics. So companies could do whatever they wanted. A lot of so-called green products weren't really green, so they just had a good marketing but lacked actual technical backing. Countries had their own eco labels. So like Sweden had TCO certification, Germany had Blue Angels, Scandinavia had Nordic Swan, and the US had the Green Seal. So these labels all use different scoring system. So it was nearly impossible to compare two products internationally. Big name OEMs like HP or Apple or Dell or Lenovo created their own in-house standards that helped them but created a chaos for suppliers. So small manufacturers had to jump through multiple hoops to meet every big company's different expectations. And at the same time, we were seeing a growing mountain of a discredited electronic piling up in the landfills. Okay, many of these electronics contain hazardous substances like mercury, cadmium, or lead, which were leaching into the soil and water. So without a unified sustainability approach, basically efforts were disconnected and often fell short of having a real environmental impact. Now, this standard is all about measuring and improving the environmental impact of electronics across their entire lifespan. It lays out material rules like banning hazardous substances and aligning with the global chemical laws like RoHS and REACH. It encouraged designers to think about how easy it is to repair or upgrade or recycle the device once it's in the user's hands, and it looks at how much power a device uses while running or sleeping or idling, and pushes for actually energy efficiency. Even the packaging is part of this scope. So manufacturers should use recycled materials and avoid hard to recycle plastics like PVC or foam. It also includes corporate ethics. So things like how companies report environmental metrics and whether their supply chain respects labor rights. But it doesn't cover electrical safety. Okay, it doesn't touch electromagnetic interference. It doesn't include mechanical performance. So basically, IEEE 1680 is there to evaluate the product's sustainability. It's not the technical performance or physical safety standard. Excuse me. Now, electrical safety is completely outside of these standards ESCO. So if you wanted to know if something will shock you or catch a fire, you need to look at the UL or IEC standards. It doesn't cover how the device manages the electromagnetic interference. Okay, so that's the job for a CISPR standard or FCC. And it doesn't test whether a device can handle drops, shake, or extreme temperatures. Those are handled in military or industrial standards that are specifically developed for each individual technology and equipment. And it also doesn't tell you how well the parts work from electrical standpoint. So IEEE 1680 works alongside these other standards. Its job is to make sure you're designing the products that are environmentally responsible. They are not just technically sound. Now, IEEE 1680 doesn't just say whether a product is sustainable or not. It gives the product different levels of certification. We have bronze, silver, and gold. These levels help manufacturers actually and buyers to understand just how environmentally responsible a product really is. So bronze is the starting line. To get it, a product must meet all the required criteria, no exceptions. But silver means that the product meets all the required criteria and also earns at least 50% of the available optional points. So it does extra work on sustainability. Now, the gold is the top tier, which products that go above and beyond, so meeting all the required items and also cover 70% or more of the optional points. Now, required criteria are the most have, so you can't skip these if you want certification at any level. Now, optional criteria are where manufacturers can show off by doing more. So these give them extra points toward a higher rating. Now, the balance between the required and optional is intentional. So it ensures companies don't just excel in one area while ignoring the rest. So each product category, like desktops, laptops, monitors, printers, they has a customized scoring system. That way, what counts is a strong sustainability effort, and it depends on the type of the product being rated. Okay, this tier system basically encourage progress. Even if a product start at bronze, manufacturers can aim to gain a silver or gold next time around. Now, IEEE 1680 uh, takes what is called a life cycle approach. Okay, so that means it looks at everything a product goes through from the birth to retirement and checks the environmental impact at each stage. So first, You've got the upstream supply chain, when there's a raw material extraction, component manufacturing, and assembly. This is where materials like metals, plastics, and chemicals are sourced and processed. Now, next comes the use phase. This is all about how the product performs once it is with the customer. So its energy consumption, emissions, and whether it can be upgraded instead of the replaced. So this is the second step. Now, next one is the maintenance and support. It answers the question that can the product be repaired easily, or are framework updates available, or are spare parts accessible? And finally, there is an end life management. So does the manufacturer offers a take back program, or can the product be recycled or safely dismantled? Now, IEEE 1680 encourages manufacturer to calculate the carbon footprint. So energy paybacks times is also important, and toxicity adjusted mass for each stage. Now, this holistic look helps manufacturers basically design smarter, not just for today, but for the entire lifespan of the product. Now, IEEE 1680 has two types of criteria. One is the requirement, and another one is optional. So understanding the difference is a key to understanding how the scoring works. So required criteria are non-negotiable. So if a product misses even one of these, it's not getting certified. Now, optional criteria let manufacturers show off a little. So these are extra sustainability features that earn points and push a product toward like a silver or gold level. Optional points usually range from 1 to 5, depending on the environmental impact. The more meaningful the environment, the more points it's worth. So all the optional points a product earns are added up to calculate the total sustainability score. So when we talk about the bronze, all required points are necessary, optional can be 0. When we talk about the silver, we have the required points plus 50% of optional, and in gold, we have required plus 75% of optional. This approach basically encourages well-rounded improvement, and you can't just focus on one thing like packaging and ignoring everything else. Now, IEEE 1680 is very organized. So every criterion is broken down in a way that tells you exactly what's expected, how it's measured, and what proof you need. So each item has a name and a reference code. Okay, this helps you find it quickly, and there is an applicability notes that explains which device it applies to. For example, some criteria might only apply to a printer or laptops. We have a measurement methodology that tells us how to verify the claim, like what kind of testing or documentation is needed. And there is always a threshold. So this is the exact number you need to hit, like having more than 30% post-consumer recycled content. Now, evidence required includes things like a third-party test result, or data sheets, or certifications, or design schematics. If it's an optional criteria, okay, it also tells you how many points it's worth. So audit frequency is listed too, and some things are checked once and others every year or when something changes. These are the important part about the structure of any single criteria. This structure makes the standard predictable and transparent and fair, basically. So manufacturers know exactly what to do, and auditors know exactly what to look for. Now, optional points in IEEE 1680 aren't just scattered all over. They are grouped into categories based on what part of the product or company they affect. So we have materials and substances, which is maximum 20 points. This includes using safer materials or reducing toxins or upping the recycled contents. Okay. We have energy efficiency, which also the max point is 20. The points here come from the reducing the power used during the normal operation or standby or sleep modes. Another category is the end of life design. The maximum point that they can earn in that category is maximum 15 points. This basically rewards the products that are easier to disassemble or repair or recycle. We have packaging, which the maximum points is 10 points, and basically products earn points for using recycled packaging and avoiding things like plastic foams. We have corporate responsibility. The maximum is 15 points. This looks at the environmental reporting or labor conditions and responsible sourcing in the supply chain. We have innovation and bonus, which is a maximum 10 points. And it means like if a manufacturer comes up with something totally new and effective for sustainability, and they can earn bonus points. These caps keep the scoring balanced so no single category can dominate. So you have to do well in multiple areas to get a gold. Now, the setup encourages manufacturers to think about the whole picture, not just make one flashy change and call it a day. Now, let's walk through how product actually gets certified under IEEE 1680. It is not just a checklist, it's actually a whole process. First, the manufacturer does a self-assessment. This usually means their internal sustainability or compliance team reviews the product and checks how well it aligns with the IEEE 1680 criteria. They gather documentation like test result, design spec, or supplier declaration, and to back up their claim, basically. Then comes the external review, an independent third-party groups that normally they call conformity assessment bodies, CABs. They come in to do a full audit. These audits are true, so they include material verifications or emission testing, tear down inspections, and corporate policy review. So once the audit is passed, all supporting documents like test reports, certificates, score calculations are all submitted to a EPEAT registry. That EPEAT is a public online database where certified products are listed. Anyone can look them by the brand or category or certification level. Okay, the product is officially registered as bronze, silver, or gold, depending on the score. So, but that does not the end of it. So, post-certification surveillances is also a thing. So there are random audits or spot checks and even compliance-driven re-evaluations. Sorry. This whole process basically ensures an accountability. It helps the consumers and procurement agencies trust the certified products truly meet the environmental claims. Now, IEEE 1680 has some firm rules when it comes to material, especially hazardous ones. If you don't meet these, you can basically forget about the certification. So There are strict limits on toxic substances like lead, mercury, cadmium, hexavalent, chromium, polybrominated biphenyls, and polybrominated diphenyl ethers. These limits usually follow the ROS guidelines, which are required by law in many countries. Okay, so if a product uses like beryllium, say, in ceramics or alloys, uh, the manufacturer has to declare and show safety protocols for workers. Now, to prove compliances, manufacturers submit the material safety data sheets or X-ray fluorescence reports and supply chain declarations using the like a IEC 62474 formats. Now, these restrictions are mandatory. They are not optional. So you can't even get Brown certification without checking these boxes. Controlling hazardous substance protect basically workers, users, recyclers, and environment. It's a win across the board. Now, another major aspect is energy efficiency. IEEE 1680 also includes energy performance criteria, and they are not just a suggestion. They are part of the required checklist. So first, products have to meet Energy Star standards. That is the baseline. For power supplies rated at 75 watts or more, they must be at least 85% efficient at 20%, 50%, and 100% of their rated loads. Now, the power factor, which shows how efficiently electricity is used, must be at least zero point 0.9 at the full load. The sleep mode also should kick in automatically within 30 minutes of inactivity. So power use must stay under 2 watt for desktops and 1 watt like for laptops. We have off mode or when the device is fully turned off and it must use only half a watt or less. These numbers have to be measured using standard procedures like those in IEEE 62 301. So the idea is simple. The less power your product wastes, the better it is for the environment and for your customers' utility. These requirements are part of the mandatory criteria, which means a product can't even be considered without meeting them. Now, IEEE 1680 cares a lot about what happens after the product leaves the store. Can you repair it? Can you recycle it? That's what this section is all about. So we have key parts like battery, RAM, and storage that should be accessible without needing special tools. This makes repairs like quicker and easier. We have cooling components like fans and filters that they also need to be accessible for cleaning or replacement. All plastic parts over 25 grams must be labeled clearly according to the ISO 11 469. This helps recyclers sort the plastic properly. Now, batteries also need to be removable using a basic tools, not soldering or like a glue shot, And the glues or adhesive that permanently bond components are discouraged or like outright prohibited. Molded in metal inserts are only allowed if they don't interfere with the recycling process. Also, co-molded materials like plastics fused with metals are limited since they are hard to separate and recycle. The whole point here is to make the product last longer and make end of the life recycling a real like workable option. This design approach supports circular economy goals like reuse, repair, and recycle, okay, rather than the landfill disposal. Now, let's talk about where companies can go above the and beyond the basics. So these are the optional criteria. They aren't required for certification, but they were innovation and leadership in sustainability shown by the manufacturer. Okay. One is the materials and substance category that can earn up to 20 points. And this includes things like using a higher percentage of recycled content, or avoiding additional harmful substances, or sourcing safer materials. In energy efficiency, which is beyond the baseline, and it worth another 20 points. It happens so if your product performs even better than Energy Star requirements, you're rewarded for that 20 points extra. Now, the design for longevity and upgradability offers like up to 15 points, which means using modular design that offering a long-term software support and making upgrades easy for users. Now we have the packaging and shipment efficiency also that can earn up to 10 points, and this encourages using less packaging or recycled materials and smarter logistics. Now, the corporate performance category also contributes up to 15 points. This looks at how well a company manages its environmental performance overall. So it includes like transparency or ethical sourcing and fair labor practice. As we mentioned earlier, we have an innovation bonus that adds up to 10 extra points. And this is for companies doing something truly new that isn't already covered in the standard, but clearly helps the sustainability. Now, these categories let the manufacturer show leadership in a ways that makes sense for their product and business. Now, the point distribution across category is designed to push companies to improve across the board. So it's not just one area. A product that maxes out in just energy or packaging wouldn't hit the gold certificate unless it also makes meaningful improvement in other areas. Now, IEEE 1680 doesn't exist uh, like in a bubble as a solo standard. It's designed to work alongside other major environmental and safety standards from around the world. So that way, companies can meet multiple requirements without duplicating their work. So it's closely aligned with RoHS, which is the European restriction of hazardous substances. And if a product already meets RoHS, it's well on its way to meet IEEE 1680's material criteria. It also supports REACH, which is another European regulation focused on chemical safety and disclosure. So IEEE 1680 actually encourages similar material transparency. For energy efficiency, IEEE 1680 references the Energy Star benchmark. So if your product is Energy Star certified, that checks off a big chunk of energy requirements. There is ISO 14001 that comes into the play as well. So it is an international framework for environmental management system, and it aligns well with the corporate responsibility expectation of IEEE 1680. When we talk about declaring the material content, the IEEE 1680 points to IEC 62474. That is the international standard for reporting materials in a consistent and a traceable way. Now, There is another digital guidance which called OECD due diligence. Now, this deals with ethical sourcing, especially for mineral. So IEEE 1680 aligns with this by requiring companies to address responsible supply chain practices. And by syncing up with these major global standards, basically IEEE 1680 helps reduce the audit burden for companies and supports international product distribution. It also encourages companies to take a system thinking approach, looking at the big picture of the product design or supply chain or energy, waste, and ethical all together. Now, in short, IEEE 1680 helps companies build sustainability into their product in a way that makes global compliances simpler and more strategic. Now, this is our discussion for IEEE 1680. If you have any question, please let me know and have a great rest of the day.